Hey Chem Kids, Underwood here with another webcast having to do with ice tables. This is going to correspond with the worksheet that we gave you in class. Watch and enjoy. Now it all really has to do with this value K. K is the equilibrium constant. If you want a definition of K, K is the ratio of the equilibrium concentrations of the products raised to the power of their stoichiometric coefficients to the equilibrium concentrations of the reactants raised to the power of their stoichiometric coefficients. That sounds complicated, so I'll go ahead and show you with a generalized K equation. Notice K is equal to the concentration of product C risen to the coefficient in front of C times the concentration of product D risen to the coefficient in front of product D divided by the concentration of reactant A risen to the coefficient in front of A times the concentration of reactant B risen to the coefficient in front of reactant B. Now let's go ahead and practice by writing an expression for K. We can use this following equation. Acetic acid neutralizes sodium hydroxide to get sodium acetate in liquid water. In writing my K equation, K is going to equal the concentration of sodium acetate risen to its coefficient, which is 1 in this case, divided by the concentration of acetic acid risen to its coefficient, which is 1, times the concentration of sodium hydroxide, which in this case, the coefficient is 1. Now notice, I did not put water in my K equation because I never put water or any other pure liquids or solid compounds in my K expression equations. Now you might be asking, what is an ice table? Well, an ice table is a tool that chemists use to find what the concentrations of reactants and products are going to be at equilibrium. I'll show you how to write one. I stands for the initial concentration. And so I is going to be the concentration of A. B is going to be the concentration given for B. Now C and D are products and they haven't begun to be made yet. So their concentration at the start is 0. Now C is equal to the change in concentration. So C for the reactants is going to be negative the coefficient of each, little a, and X being the unknown concentration. Same goes for reactant B. Negative coefficient of B times X, the unknown concentration. Now on the product side, the products are going to increase. And so this is going to be plus coefficient X plus coefficient X. So then to write our expression at equilibrium, it's going to take the concentration of AA minus AX. Same goes. Concentration B, big B, minus BX. In this one, concentrations are going to be CX, concentration DX. So now I can write my concentration for K. K is going to be equal to the new concentrations of my products risen to their coefficients divided by the new concentrations of my reactants risen to their coefficients. Now let's go ahead and try it. In the dissociation of acetic acid and water, what will the concentration of hydrogen ion be at equilibrium when the starting concentration of acetic acid is 0.100 molar? In this case, K equals 1.8 times 10 to the negative 5. Now I can go ahead and write my equation. Acetic acid dissociates to make hydrogen ion and acetate ion. You're going to be given different equations, and you will have to balance them before you continue. In this case, I've already done it for you. Now, I stands for the initial concentration, and in my problem, it gives me initial concentration of acetic acid as 0.100 molar. My two products have not begun to be made yet, so their concentration begins as 0. Now, C stands for change. The acetic acid is going to be used up as it dissociates, and so my concentration of acetic acid is going to go down. But it's going to go down by an unknown amount, so I designate that as X. My products, on the other hand, are going to increase in concentration. But I don't know by how much, so I will designate each as plus X. Now to find E, I simply combine I and C. For my acetic acid, my concentration at equilibrium is going to be equal to 0.100 minus X. At equilibrium, the concentration of my products, hydrogen ion and acetate ion, the concentrations are going to be X and X, respectively. So now we can use the information in our ice table to write our K expression. In this problem, 1.8 times 10 to the negative 5 is our K. That's going to be equal to the unknown concentration of my hydrogen ion, as seen in my ice table, times the unknown concentration of my acetate ion at equilibrium, as seen in my ice table, divided by the unknown concentration, 1.00 minus X, of my acetic acid at equilibrium. Now, there's a rule that we must remember. When K is less than 1 times 10 to the negative 4, the change in the reactant concentration is considered negligible. And so that really helps us out, because the math would get really complicated. We'd have to use the quadratic formula and all these things. So instead, I can simply scratch this out, because the value of my K is less than 1 times 10 to the negative 4. This makes my math much more easy. So now I'll cross multiply. And I find that X times X is X squared. And that will be equal to 1 times 10, 1.8 times 10 to the negative 5 times 0.100, which is equal to 0.000018. I can find the square root of both sides. And this tells me that X is equal to 0.00134. Now remember from my ice table that X is equal to the concentration of my hydrogen ion at equilibrium. So this is equal to H plus concentration. That is how you create an ice table, and that is how you solve using your K value for concentrations of unknown products at equilibrium. I hope this video was helpful. If you have any questions, please ask us in class. Have a great weekend. Talk to you soon.